In this video, we're going to be looking at graphing quadratics in standard form, or what I often call vertex form. In the first example, sketch the graph of f of x is equal to x minus 3 squared plus 5. Now, before I graph that parabola, what I want to do is, or what I'm going to do, is I'm going to graph the parent function y equals x squared. And then I'm just going to go ahead and erase it, and then we could graph this function that we're being asked to graph. So y equals x squared, if you remember, we could make a quick table even, okay? So, all the y values are the squares of our x values. And we can do this really quickly. I don't have 3, but 3 would be 9. Let's see, 4, 5, 6, 7, 8. That'd be up here. So this is the graph of the parent function, y equals x squared. The reason I'm drawing this is because I just want to point out the pattern of points on the graph. So here's our vertex. The first point to the right is 1 unit to the right, 1 unit up. From that point, the next point on the graph is 1 unit to the right, 3 units up. The next point is 1 unit to the right, 5 units up. So each point is 2 units higher than the next, and you can see that those steps are odd numbers. Okay, the point after the third one on the right is going to be 1 unit to the right and 7 units up. And I want to point that out because it's going to make graphing a lot easier when we're graphing other quadratics with vertexes in other places. So here we're going to graph this parabola. It's at, again, the equation is x minus 3 squared plus 5. So the vertex is at 3, 5. So when a quadratic is in standard form, it is in the form y equals a times x minus h squared plus k, where the vertex is at h, k. So the form of this equation has a minus sign right there. So this minus sign right there is part of this form of the equation. And the vertex has an x-coordinate of positive 3, even though it looks like it's negative 3 in the equation. If we were looking at an equation where there was a positive number there, the vertex would be at a negative number. So we have a vertex at 3, 5, so that's 3 units to the right, 5 units up. And now from there, we're going to graph this parabola. Now, I'm right at the edge of my graph. I'm going to go off the graph pretty quickly. Okay? So from here, I'm going to go 1 unit to the right, 1 up, and then 1 unit to the right, 3 up. So that puts me off the graph. And then I'm just going to mirror that over the axis of symmetry on the left side. Okay, and I have my equation. So let's look at another example, B. So we have g of x is equal to x squared minus 3. So this graph is also in standard form. Excuse me, this equation is also in standard form. We can think of this as being x minus 0 squared minus 3, where my vertex is going to be at 0, negative 3. So remember, if we have a negative sign here, that our x-coordinate is going to be the positive version of the number that we're looking at. Because this is 0, 0 doesn't have a sign. And our minus 3, our y-coordinate, is exactly the coordinate that we're looking at. So let's put our vertex at 0, -3. And then from that point, we're simply going to make our steps, okay? 1 to the right, 1 up, 1 to the right, 3 up, 1 to the right, 5 up. And then our axis of symmetry is the y-axis, and I can reflect all of these points over the y-axis here. And here is our parabola. So that is how you graph parabolas that are written in standard form, otherwise known as vertex form.